Hello everyone. This is Kanishka Rajvansh,
And this is Ankita Saxena.
and we are from the Team Grey interface of the Hackslash Developers Club. And today we'll be taking our session on the topic Exploratory Data Analysis, that is EDA. Our today's agenda would be first of all, we'll be giving an introduction to EDA. In this section, we'll be covering what is EDA? When do we use EDA? What is the importance of EDA and how to perform it? We'll start by understanding our data set. Then we'll be performing some data visualization. And then we'll learn how to handle missing data present in our data set. After that, we'll be performing feature engineering on our data set. So let's start. First of all, introduction to EDA. Exploratory Data Analysis. That is EDA. It is the process of analyzing and summarizing data sets to understand their key characteristics before applying modeling techniques. What is the importance of EDA? EDA is crucial for identifying patterns, trends, and anomalies while understanding data distributions, detecting missing values and outliers, and performing feature selection and transformation to enhance model performance. Now, EDA is also categorized into various types. It includes univariate analysis for single variable insights, bivariate analysis for relationships between two variables, multivariate analysis for interactions among multiple variables, and textual or graphical analysis for summarizing data using statistics and visualizations.
Next up, we have is understanding our data. To understand our data, first of all, I'll have to show it to you using Google Colab. So let's just go to Google Colab. For to understand our data, let's just pick up a data set. So the most popular one is Titanic data set. And to find it, you just have to go to Kaggle and register yourself. Type here Titanic, enter, and I'll be downloading this one. Right, now you will have to go to datasets. This second one, I'll be showing you on the second one. You can download anyone. So download. I have already downloaded. So moving on. Let's go to Google Colab. Let's just go to new notebook. So our new notebook is open now. I'll just start by changing the runtime to GPU so that it just processes it a little bit faster. Next up, we'll have to go to files and now here upload. By clicking on this, we'll be uploading the data set on which we'll be performing EDA. This and then open. Okay. Now you can see our data set is being uploaded. The data set is already uploaded. Now, what is the next step? For this, I'll be mounting my Google Colab notebook to Drive. What will this do? This will help me save this notebook in my Drive. And for this, I'll be using the same email, obviously. And it is mounted on Drive. And hence, the code will be saved and I'll be able to access it in future for reference for other data sets and everything. Next step is now I'll be starting coding part of this session. So first of all, let's just start by importing the basic libraries like NumPy as NP, Pandas as PD, matplotlib as plt and seaborn as sms. Now I'll be running it. So all my basic libraries are imported. Now what I'll do is I'll create a variable, a df variable to store the, to read my data set. For this, I'll be using the read CSV function of the pandas library. Why am I using read CSV? Because it is a CSV type dataset. CSV is a comma separated file. Now, how will I put the path here? For this, I'll have to go again to the part where I uploaded my dataset, which is this. I'll click on the three dots and then I'll go to copy path, close it, and then Control V and run it. Now the dataset is gone to this variable. To see it, you can simply uh, write date and run it, and it will show you all the contents of the dataset. Just an overview to see what type of data is here, what is how many rows are there, how many columns are there, and what is in each row and column. Now to go in detail into the data set, I'll be going with a function called head, df.head. This will show me the first 5 rows of the data set and what is inside them. Now, this is how I did, this is by default, but I can also write how many rows I want to see. Like I can write 10, it will show me 10 rows, the data of 10 rows. I can write 15 to see the data of 15 rows. It's up to me. Now, similar to head, we also have another function called tail, df.tail, to see the bottommost 5 rows of my dataset. These are all just done to get an overview of the dataset and the type of things there are in the dataset. Now, moving forward, I'll go with df.shape. Now, it will give me the number of rows in my dataset and the number of columns. So, in this Titanic dataset, we have 418 rows and 12 columns. Next up, we can go with info, and info shows me the type of data type that is stored in each column. Like passenger ID stores int type data type, and name is of object type, and so on and so forth. So, totally, 2 columns in my data set store float type data, 5 store int type data, and 5 store object type data. That is what the information about my data set is. Now we can go with df dot describe also to go in detailed description of the data set. Now it will show me the count, mean, standard deviation, min, percentages, max, these values of the data set per column. Like 418 count is the total count for passenger ID and everything. It gives values for all the numeric columns only. The mathematical values are there, so they are for the numeric column. Moving on, we can go we can go with a lot of things to get an overview of the data, and this is the basically the available information about the data set and everything that we can see by these functions. Now we'll be moving.
So now we'll be looking into our data set and we'll try to find out whether any null values are present in our data set or not. So for that, we'll be using a function called isNull. Let's just see. So here, look. The isNull function shows whether our data is a null value or not. So it will return either true or false. So using this function, we can know whether our data is a null value or not. Next up, if we want to see the total number of null values in each column, so we are having a function for that too. Let's see. So here it is. The dot is null dot sum. This gives us the total number of null values in each column. So from this we can see that our column passenger LD is having no null values. Similarly, name is having no null values. But there are certain column having a lot of null values like the age column, which has 86 null values. The fare column has a single null value. The cabin column has 327 null values. So, using this, we can get a brief about how many null values are present in each column. So, using these two methods, we can check about the null values present in our data set. Okay. So, till now we have seen how to check the missing values, and now we want to generate the fraction of missing values in each column. So for that, we'll be creating a function. Let's do that. We'll be passing a data frame df in it. Then df dot is null dot sum by len df. Len df basically gives us the length of the data frame. So we have created the function. Now let's run this. So our function has been created. Okay, we have defined our function using a def method, and we have passed a df data frame in it. Now let's see. Um, we'll be printing print fraction underscore missing. That is our function name, and we'll be passing our data frame in it. So let's run this. So here you can see that our age column is having 0.2 uh, percent of missing data. Our fair column is having 0.002392 percentage of missing data, and a cabin column is having 0.78 percentage of missing data. So, what we have learned is that we have created a function that returns the fraction of missing data in a particular column. Okay, so next up, we'll be creating another function. Uh, Through this function, we would be knowing what is the type of our columns. That is, what is the percentage of numerical columns, the percentage of categorical columns, and the percentage of text columns in our data frame. Okay, so let's create a function. We'll be using def. Our function name is column underscore types, and we'll be passing data frame. Hmm. Look, we have in this line we have written numerical is equal to df dot select underscore d types. We are using select underscore d types function. We'll be passing some parameters like include is equal to number dot columns. Categorical is equal to df dot select underscore d types, and exclude is equal to number comma bool underscore comma. Okay, next up we have object select underscore dtype function will be including include is equal to object. Hmm. And then dot columns. Object one total columns, then be returning numerical um, numerical underscore fraction, categorical categorical underscore fraction, text text underscore fraction. Okay, so we have created a function called column types. using the def method. And now let's run this. Hmm, showing error. It's showing error. Actually, I've missed comma. Hmm. Now let's run it. Yeah. So our column types function has been created. Now let's print it for our df data frame types. We'll be passing our df data frame. Okay. So yeah, in our data frame, the fraction of numerical columns is 0.583. The fraction of categorical columns is 34.833, and the fraction of text columns is 0.416. So we have successfully created a function, and and we have seen what is the fraction of each type of column in our data frame.
Moving forward with EDA now, next up we'll go deep into data visualization. So let me just write it down here. Okay. So let's just start with creating a heat map of the for this data set, which will show me what all null values do we have per column. Df dot is null, comma, while tick labels equals false, because I do not want any labels, and then c bar equals false. Now run it. So this is giving me the heat map of my data set. All these white lines here against the black background are showing me the null values. For example, like in age column, I have a lot of null values. In fair column, I have one null value. In cabin column, I have a lot of null values. That is what the heat map is showing me, the null values per column. Next up, let's create the count plot per column for this data set. So first of all, I'll just create a count plot for survived column. X equals survived, comma, data equals data. So this is giving me the count of the all the people who did not survive, and the one represents the number of people who survived, which is around 150 people. Next up, let me show create the count plot for the number of people against the for the number of people for so it will show me the number of people who survived in the two genders, which is male and female. So for this, SMS dot count plot now x equals survived, comma u equals x and data equals data. No. So this color represents female and blue represents male. So in males, how many people did not survive? Um,
Yeah.
no, it is showing how many people survived in males and in females. Next up, we have now we'll plot a count plot for the number of people who survived or passenger class. Like in each passenger class, how many people survived? X equals, comma, U equals B class, comma, theta equals T. Now, see, these are the number of people from third class who did not survive, number of people from second class who did not survive, from first class who did not survive, and one represents the people who survived. So, likewise, moving forward, now let's create a dist plot for the age column. SNS dot dist plot tf, let's go with age, comma, let's give kd equals false because I do not want the kernel distance line in it. Base equals 40. Let's just take 40. So this is giving me the dist plot, which is like the number of people in various different age ranges, like from 30 to 40. How many people are there between 30 to 40? Moving on. Now let's plot a count plot for the sibling SIBS, SIB-SP relationship, sibling spouse relationship. So you guys did learn how to plot the count plot at least for every column, and we learned how to plot the heat map, the dist plot. So moving forward, let's just plot one more dist plot for the fair column because we're doing EDA, so why not fair? KD equals false. Let's change the color to green and let's take for this is the count plot for fair column. Now we can also plot a KDE plot. There is also a KDE type of plot. So
Next up we'll be plotting a KDE plot of age distribution. Before plotting our KDE plot, I would like to give you a brief introduction about KDE plot. In Python, a KDE plot, that is kernel density estimation plot, is a method for visualizing the probability density of a continuous variable. Okay, so it gives the probability density, that too of a continuous variable. It is similar to a histogram but provides a smoother and more continuous estimate of the data distribution. Okay, so there is one key point, that is, unlike histogram, KDE plots do not depend on bin sizes but instead use a kernel function to estimate the density. Okay, so now we have an idea about what is KDE plot, and let's create a KDE plot of age distribution. Okay, plt.figure, I'll be giving fig size is equal to 8 comma 5. Next SNS dot KDE plot, I'll be passing df age column, dot drop na. I'll be giving fill is equal to true. Um, Color is equal to blue, and I'll be also providing line width. Let's give it 2. Okay. Hmm. Then let's give a title, plt dot title. Our title would be KD plot of age distribution. Hmm. Okay. Let's now give X label. Hmm. X label should be age. Hmm. And Y label. Y label is density. Hmm. Now let's just do plt dot show. Let's first run this. Hmm. So here we have a KD plot of age distribution. This is what a KD plot looks like. And here we can see that since we have given fill is equal to true, therefore this KD plot is filled like this. Now look, if I don't give fill is equal to true, then fill would remain with its default value, that is false, and our KD plot would look something like this, but I want fill is equal to true. Hmm. Yeah, so this is our KD plot of age distribution. Next up will be plotting a hist plot. Let's see plt.figure, sorry, fig size is equal to, let's give 8 comma 5. Hmm. And sns dot hist plot df age dot drop na bins is equal to, let's say, 30, and let's give kd is equal to true. That is, I want to show kd plot as well, and let's give color is equal to blue. Yeah, so let's run this. Yeah, so here it is a hist plot, and since we have given kd is equal to true, therefore a kd plot has also been created. Now next up, let's create a cluster map. Okay, so let's write a code for it. We'll be dropping, yeah. Hmm. Hmm. Passenger ID, come on. be dropping ticket as well. Pin bar and, and will pass axis is equal to 1. Okay. Um, by this line, we have selected our relevant numerical features for clustering. Then underscore cluster is equal to df underscore cluster dot drop in. Using this line in our code, we'll be dropping rows with missing values to avoid any error. Now let's create the cluster map. SNS dot for creating the cluster map, we are having our cluster map function in the Seaborn library. Df underscore cluster comma will be giving anot is equal to true. Let's give fixed size. We'll be passing fixed size as 10 comma 8, and like let's give a color ratio as well. Colors ratio, let's give it 1.2. Okay, then we'll be doing plt dot show. Let's run this and see our cluster map. There is an error. Let me check. So it would be small d. Yeah. Now let's check. Yeah. So here is our cluster map, and since we have also given a colors ratio, so it is coming in this color palette. We can also change it according to our choice. Next up, we'll be creating a box plot. SNS dot box plot will be using the box plot function from the Seaborn library. And we'll be passing data as a data frame df. Okay, so I've passed x is equal to p class, y is equal to age, and data is equal to df. Now let's run this. So yeah, here is a box plot. Now from this box plot we can see that in P class 1 our median age is around 41 or something. In P class 2 it is around 25 or 26. Okay. And in P class, that is passenger class 3, it is, I guess, around 23. Okay. So we are getting all these information from our box plot. So with this, we have completed our data visualization. We have visualized our data frame and learned various plotting techniques used for visualizing our data frame df. Now we'll be moving forward and we'll learn how to handle missing values. Okay.
Missing values.
Hmm. Hmm. So let's start. Now, I'll be for handling missing values, I'll be creating a function first. Okay. So our function name is impute underscore age. Will be passing columns calls. Okay. Age is equal to calls 0. Next, p class is equal to calls 1. If we'll be using if statement. If pd dot is null, we are using the is null function of pandas library, and I'll be passing age. Okay. Then we'll be writing if p class is wait equal to 1, then I'll be returning 41. As from the box plot, we have seen that for passenger class 1, it the median age is around 41. So we'll be returning 41. Now, elif. Elif. Okay. Elif p class is equal to 2. That is for our passenger class 2. From our box plot, we can see that for the passenger class 2, our median age is around like 25 or 26. Okay, so we'll be returning 26. Let's say 26. Okay, and else else will be returning from the box plot. We can see that if our passenger class is 3, then our median age is around um 22 or 23. So let's return 23. Hmm. Hmm. Else return age. Let's run this. So our function impute underscore age has been defined. Now let's apply it. df age is equal to df plus hmm, we'll be using dot apply impute underscore age comma will be giving access is equal to 1. Now let's run this. Yeah, okay. Now using this function, wherever there was any null value, then if the passenger class was 1, then instead of that null value, it will now show 41. Similarly, for passenger class 2, it will now show 26, and for passenger class 3, it will now show 23. So let's check this. And for this purpose, we'll be using a heat map. For
Easy.
verifying for verifying this, we'll be using heat map. So let's create a heat map. SNS dot heat map, and df dot is null. We'll be passing df dot is null. Okay, so now let's run this. Yeah. So now we can see that for P class there is no null value since we have replaced it with our median ages, and we got that from our box plot. Okay.
Next up, we can see we have one null value here in the fair column. We'll see how to deal with it. For this, I am thinking of filling it with the mode of all the fair values. So for that, the code will look like this. Here, fair dot fill now, and then df, and again fair dot mode, and then 0 comma in place. This will go inside the, one second, this will go inside the fill now function. Dot mode, then 0 comma in place equals true. This is giving an error. So the error is here, the column name, it is not false, it is fair. So it's done. Now to verify this, let me just do again df dot is null dot sum. See, it is showing 0 null values in the fair column. To verify it further, I can do again a heat map, sns dot heat map, df dot is null. See, now there are no null values in the fair column. Now the only null values left are in the cabin column. But I don't think that this column will have any effect on any of the training I'll do to this model, because why are we doing everything to this model? We are preparing our data to fit into an ML model to continue to predict something and to get an answer to some to do ML model predictions basically. So I don't think the data from the cabin section will play any role in it. So I'll simply delete this column, or drop this column as we say. So for this df dot drop cabin comma axis equals 1 comma in place equals 2. Now this will delete the cabin column. You can see this using heat map again. Df dot is null dot sum. Sorry, one second. Df dot is null. So now we have no missing values in our data set. Now this will create no problem when I try to do some predictions. Our data is ready in terms of missing values for to fit into any ML model for predictions.
So, till now, we have completed most of our agendas. We have seen what is EDA. We have also took our time to understand the data set. Then we also performed data visualization and have also handled our missing data. Now, the next part of our today's session is about feature engineering. So, I'll be giving a brief introduction to feature engineering and I'll be telling its importance. Okay, so first of all, what is feature engineering? Feature engineering is the process of creating, transforming, or selecting features to improve a machine learning model's performance. Okay, so using feature engineering, we select and transform our features in such a way so that we can improve our machine learning model's performance. Now, what are features? Features are our input variables. Feature engineering plays a crucial role in extracting meaningful information from raw data. Okay, so in simple language, we can say that feature engineering means creating better data for a ML model to learn from it. Okay, it helps the model understand patterns and make better predictions. Now, we know what is feature engineering, but why is it important? So, now imagine if you're teaching a child to recognize animals, and if you only show blurry pictures, then they may struggle. But if you give clear images with extra details like size, color, and habitat, they'll be learning faster. Similarly, good features help ML models learn better. Okay, so now we know why feature engineering is important. So let's see, there are some common feature engineering techniques. First of all, filling missing data. If some data is missing, we fill it with a reasonable value. Next, we can convert text to numbers. Like if data has words, like in the form of text, for example, if gender is mentioned like male and female, we can convert them into numbers so the model can understand. Okay, next up, we can also scale our numbers. Now, look, if one column has values from 1 to 10 and another has, let's say, from 1000 to 10,000, we adjust them to a similar scale. Okay, now we can also create new features. For example, if we have a date of birth column, we can create a new age column for it so that it would be more helpful. And also, we can remove some useless features. Like if a column doesn't help in making predictions, we can simply remove it. So, in short, feature engineering is like cleaning and organizing data before feeding it into a model so that it can learn better. Next up will be seeing how to perform feature engineering on our Titanic dataset.
So I will explain you what how to convert categorical data to numerical data. Because our data set has some categorical data in certain columns which are important to the prediction of our model. Let's just look at it. So yes, here we can see like the name, then the sex column, and then there is the ticket column, an embarked column. These have categorical data in them, which we'll need to convert to numerical data because the ML model can only do predictions on numerical data. So for this, I'll be teaching you one encoding technique, which is one hot encoding. Now, what is one hot encoding? It is a technique used in machine learning to convert categorical variables into a numerical format that can be used by models. It is particularly useful when dealing with categorical data that has no inherent order, such as colors, names, or categories. Like the data for embarked has no particular order, or assigning it different numbers does not mean a particular order. So, how does one hot encoding work? So each unique category in a feature is represented as a separate column in the dataset. If a sample belongs to a particular category, the corresponding column gets a 1 while all the other columns get a 0. You'll better understand this when I'll start coding for it. So I think I should go and show you how to do that, how to do the conversion of the categorical data to numerical data. Now I'll perform one hot encoding on the embarked column in my dataset. For this, first of all, let's just see how many unique words we have in this column. For this, I'll be using function unique. So we have Q, S, and C as the three unique functions, the three unique data in this column. Now for this, I'll be using pandas library function get dummies to create dummy variables. Dummies, df, embark, drop, first equals true dot. Now this will create two columns while at the same time dropping this one and just using Q and S as two columns. Now next one we'll do pd dot get dummies for the sex column in our dataset, comma drop cost equals true. This way we just created one column simultaneously dropping the female column. We will have to drop one column in one hot encoding. Now x equals ed dot get dummies df se x comma drop cost equals to enter embark ed dot get dummies df comma drop first equals to this thing will create two columns which will contain the data these two columns that we created earlier. So the column name would be sex and the embark. Now we'll drop the already existing columns from our data set, which is sex and embarked, and also all the other categorical columns which have no significance when it comes to doing predictions. Ticket mm, is equals 1 and in place equals 2. Now let's just look at the head of our data set. Okay, so all the columns are dropped. Now what we'll do is we'll concatenate the two columns we created earlier. df equals, for this we'll use concat function of the pandas library, and then we'll give the data set the columns to be concatenated, and then just x equals 1. Now let's look at the head. See, all the columns that I created, like male, Q, and S, they replace the already existing columns sex and embarked. So now, now let's look at the info of this data set to see if all the categorical data got converted to. See, it did get converted to bool, and the other ones which are not relevant to the data set, those are dropped. So in this way, we are left with no categorical data for our data set. Now here, most of our data is pre-processed and almost ready to get into training and test data sets and get in to make ML predictions on it. What one more thing that we can do is we can change the name of our document of our collab notebook. Let's just name it as Titanic uh, underscore EDA as we performed EDA on it. Now this will be saved in our drive with this name, and all the pre-processing is done. So now furthermore you can learn about the different ML models and put this pre-processed data into the any ML model that you want to make predictions.
So, yeah, that was all for today. Um, we have completed all our agenda for today. We have learned how to perform exploratory data analysis, and our data is now prepared and it can be used in any ML model, be it a regression or a classification model, which you'll be learning in next classes. So, yeah, that was all from our side today. Um, Signing off. Thank you.